All right, hi everyone. We're going to get started. So we're here to talk about carving up the web platform. So Ian wrote these slides. Unfortunately, he couldn't be here today, so Luna and I are taking over for him. So anything that goes well, you can thank Ian for writing good slides, and anything that goes poorly, well, you can blame me for dragging Luna up here to suffer with me. So Luna, why don't you take it off?
Yeah, so as mentioned yesterday in the keynote, we're trying to use some policies to enable some great user experience, and feature policy is a key part of it. So what is feature policy? Feature policy is a mechanism to allow web developers to selectively enable and disable certain browser features and APIs on their site. And the feature policy can be specified either via an HTTP response header or an iframe allow attribute. And here are some examples how you can specify some policies for some features. In the example, you can see full screen. The first one is an HTTP header policy. You can see full screen is enabled on self-origin and also on example.com. And geolocation is disabled everywhere. And similarly, in iframe, you see the camera feature and microphone features are allowed within that iframe. So just a quick status update since last BlinkOn we talked about feature policy. This is a diagram showing how many features we've added through Chrome versions. And yay, we added so many features. In Chrome 60, we shipped feature policy with payment request and web USB. And with helps from many teams, we managed to ship more features, such as WebVR, full screen, permission-based features, accessibility events, and et cetera, and et cetera. And now we are currently experimenting with 3 new features. For example, this default media size policy / unsized media enable developers to restrict images with intrinsic size. What it means is images or videos. So what it means is if we have an media element that doesn't have a specified size, with feature policy, we will load it with default size to prevent relayout. And we're very glad that other browser vendors are on board with us. And here are the ways you can track their progress on feature policy. So what is next? Upcoming, we're planning to ship more features, such as non-composited animations, parse blocking scripts, and a bunch of policies to enable optimized images on the web. In addition, we are planning to support JavaScript introspection with feature policy, as well with reporting systems when a feature policy is violated. And here are a list of ideas we have in mind, such as web authentication, battery status, and etc. If you have any interesting ideas, please feel free to reach out to us.
Great, thanks, Luna. So that's a bit about what feature policy is and where we're at. So going back to why we think feature policy is important. So we have this web platform, right? And so what does it look like? Well, we'd like to think there's a core of features like HTML, and then there's a bunch of optional features later on top, and that we could have this nice, layered diagram that looks something like this. Right? So there's HTML at the core, there's JavaScript, there's CSS, then we layer more features on top. And the idea is you have these optional features you could use or not, right, as you need different or more capabilities. So that would be ideal. We're not really in that world. And so where we are is we have all these features because the web has evolved over 20, 25 years. And for some of these things, when you use them, there's a trade-off. And sometimes that trade-off impacts the user experience. So what we really have is kind of this big, ugly ball that looks like this, right? And so there's we started out with HTML, I guess 3.2 in the middle. And then we've added additional versions of HTML. We've JavaScript and CSS, they're pretty tightly embedded. Then we added new things. Now we have XR, right? Things like WebXR, storage, all these things we've cobbled on the edges as we've gone along. So what we'd like to do with feature policy is give a way to start drawing lines and carving off pieces of this so you can get back to a core where it's easy to provide a good user experience. So we'll talk about carving out features, right? Starting to draw the lines in that diagram. Now, there's kind of different categories. We'll run through some examples and explain how you can do different carve-outs. So the first one, and this is some we've implemented, is just when you have a simple toggle that you can turn a feature on and off. So we have examples like full screen payment request. So these are ones that already had an allow attribute. For example, you can specify allow full screen to enable full screen. And so in many cases, they already follow the semantics of feature policy. And so I'll just talk about that for a little bit to clarify. So with feature policy, obviously there's the idea of a policy and it's on or off. And so with feature policy, once you turn a policy off, it's off for all of your nested frames and you cannot turn it back on again. So that's kind of a key semantic of feature policy that you have to remember when you're designing these carve-outs, is there's no turning it on or off as you, let's say, have nested frames. So in the case of these examples, most of them follow those semantics already, and there was just a few tweaks we needed to make. So feature policy has this concept of an allow list, and so we saw examples in the syntax there, and so what it's really about is defining who is allowed to have this policy. And so we see this keyword self. Self means the top level frame, whatever origin that happens to be. And then self also applies to any same origin frames. So for toggleable features, typically your default is going to be self. Say, I want to use it, and my same origin frames can, and by default, I want it off in cross origin frames. So this is the same as some of the existing allow attributes, minus the tweaks. And so then when disabled, it's just the same thing as saying allow x equals false. So that's the first category. Second one we have is permissions. So again, some examples, WebMIDI and so on. So we're already working on feature delegation, permission delegation, kind of separate from feature policy. So what this is an integration between feature policy and permission delegation. So if we talk about what that really means, again, let's say we have a default allow list of self, which means the top level frame can use it, but not cross origin frames. So now what happens here is when the feature policy is disabled, the permission prompt doesn't appear at all. So for example, ignoring feature policy, if you had a permission controlled feature in your script, the web developer would attempt to use the feature, it would cause a prompt. Now with your feature policy, you can turn off, so there's no prompt at all. It's just off by default, and it cannot be turned on by prompting the user. And so the advantage of this is for web developers who are interacting with the feature, it looks exactly the same. They ask for permission to use a feature, and it's denied. The web developer doesn't have to handle this scenario any differently. So for excuse me, third example is for new features. So now these are features like web USB, like generic sensors. They're new to the web, so there's no existing usage that we have to worry about. So if we contrast this to the previous examples, some of those features were already in use, so we had to design our feature policy in a way that wouldn't break existing content. So again, these features, because they're powerful, you'll typically want to allow them for your frame only and not for cross-origin. So for example, if you're embedding third-party content and you don't want them to use these features. But what this does do is it gives you a path to enabling it in a cross-origin frame in a way that you can control. So again, by default, your default allow list is self, saying I can use it as a top-level frame. But now, because it's a new feature, because it's not widely used on the web platform, now you as the designer of the feature, you have options to specify the semantics for what on or off means. And so again, you're free to define what the error mode looks like for when the feature is disabled. So in some cases, maybe you throw a security error. If it's something like you're giving access to devices, you just return an empty device list when the feature is disabled. I'll let Luna talk to you about some of our other categories.
Thanks, Jason. Contrary to the powerful new features, there are some very old features or behaviors that are making the performance terrible. And because they are used everywhere, we can't really just disable them everywhere because that will break the web. Alternatively, with feature policy, we allow developers to opt out some bad features on their website and or maybe the children of their website. For example, because we don't want to break the web, so by default we enable those features everywhere. However, through different mechanisms, we can disable certain features either from the top level document all the way down or in a certain iframe and etc. and etc. And sometimes we might want to give web developers a more granular control of some features. For example, with image formats, we might want to support the web developer to specify which format they want to enable on their site. This is why we are thinking about introducing this new syntax to allow web developers to specify like which values they want to support. For example, this animation is a list of animations we want to disable or enable, or this number, which means a downsampling ratio we want to limit on the image. And in addition, with Sandbox is an iframe attribute that sets restriction on bunch of features in an iframe, and we moved Sandbox features to feature policy while continuing to support those features with a Sandbox attribute. So what this means is we can have web developers to opt out a subset of Sandbox features in an iframe. And also, if all those features are restricted due to Sandbox attribute, we might be able to turn on some features with feature policy. An interesting thing to note about is inside of a sandbox, all the origins are opaque. Therefore, we have to treat all origins inside of a sandbox as cross-origin. In addition, with feature policy, we might be able to change the default behavior. For example, we may want to, with feature policy, we can have a web developer to select image to use lazy load inside of an iframe. So we're proposing this new iframe attribute lazy load. And when the default value for lazy load is not specified, we can use feature policy to set the default value. For example, when the feature is enabled by feature policy, then we'll set the default to be auto. And when it's disabled, we'll set the default to be off. And the default allow list for lazy load would be all, which means auto is the default for all content. But you can also embed a page which doesn't support lazy load with the default set to be off. And what is left? I'll let Jason to talk about that.
Okay, so we walked through kind of some of the ways you can carve out features from the web platform. And the idea is, well, what does that leave us with? So let's say we carve out all of the features we don't want to use, some of the features that have trade-offs, like impact performance. Well, what's left? So you could say, well, there's HTML, most of it, static layout. You know, we talked about unsized media as a policy to stop relayout as content comes in. And then CSS, again, most of it that doesn't have some of the trade-offs we're concerned about. So then the question is, well, what about JavaScript? Well, if look at like the Sandbox attribute, you look at AMP, you can see that there is modern web content that you can provide without using JavaScript. But the reality is that's pretty limiting. So we think maybe in terms of this core that you'd use to provide a good user experience, then probably we can have non-blocking, APIs, passive event listeners, things like those, maybe whitelisted script. Again, you add back a little bit of script to provide some capability, and we think this is a really great core to provide a good user experience and help you avoid some of the problematic areas. So we've come up with these features, and you saw a lot of the ones we're thinking about. So again, we're kind of ideas welcome, trying to iterate on features that will get us to a really great core. This is not unlike what AMP did, right? Like AMP defined very restrictive set of things you could do, right? And they have a bunch of validation to enforce it. But again, they got to a core where you could provide content that was pretty much guaranteed to give a good user experience. And then once we have something like that with policies, then we can think about what additional policies or what additional features you want to layer back on. So to summarize, there's a bunch of considerations for when you're designing your feature to integrate with feature policy. And we've seen a lot of examples. So default state is a big one, right? You saw, should your allow list by default? And by default, we mean, what if you're running content, let's say in Chrome, that's in a browser that supports feature policy, and no feature policy is specified? That's what we mean by the default allow list. So you have to think, for any feature you're going to integrate with feature policy, what is the right default state? And in many cases, this is tied to existing usage. So we saw with kind of option 4, the carve-outs, really your allow list needs to be star, which means anyone can use it, because if you had a different default, then you're going to break content that is not feature policy aware, and all of a sudden the feature isn't working for them. So default state, existing usage, often related. Those are ones you need to think about. Another big one is origin boundaries. So again, for many features, you want your top level frame to be able to use it, i.e. self, and cross-origin frames disabled by default. But again, for any given feature, where you draw that line as enabled by default or disabled by default might be different, so you need to think about the cross-origin case. The big, I don't want to say big, but a tricky one can be failure modes. So if we use the example of synchronous XHR, we recently shipped a policy to disable that. So that means if you enable this policy, you cannot use synchronous XHR. You can still use async. And so we think this is a great policy to make sure we're not doing blocking network calls, right, to impact the user experience. But there was some discussion about, well, what is the right failure mode for synchronous XHR? Because lots of people are using it, and we don't want it to all of a sudden stop working in unexpected ways. So in that example, what we landed on is that if you have this feature policy to disable sync XHR, and you try to use it, we'll raise a network error. So the thinking being that developers, if they're using sync XHR, they'd have to already handle network errors. So that's a natural failure mode for them to already be handling. So failure mode is a big one to think about if you're designing a feature to integrate with feature policy. Again, we saw examples like permissions where there's an obvious, they're used to handling permission being denied, but you need to think about, do I throw an error? Do I have a return code or whatever the case might be? So I think that kind of summarizes the considerations. If you want more information, the GitHub is a great place to go. So that talks explainer, et cetera, talks a lot about what is feature policy and the nuts and bolts. But that's also where we're also collecting ideas for feature policies. And if you go look at the issues, you'll see some of the ones we've either implemented or we're thinking about. And then finally, feature control at chromium.org. That is a mailing list that our team, so Luna, myself, Ian, and others monitor. So you are welcome to drop us a note there if you have any questions. So that's it. I think we have lots of time for questions if people have any. And if they're not, that's fine, because I don't want to be the one that has to say, I'm going to delegate that one to Ian. Ah, darn it.
One of the things you're controlling is image downsampling. What's the use case for that? I don't get that one.
Oh, so this is part of a optimized image policy. So right now, like image makes up a big proportion of web content, and so optimizing image really can optimize the performance a lot. But sometimes it's sad to see sites are shipping desktop-sized images on a mobile phone, and And you know the resolution on a web page is really just based on how many pixels we can render. So then it's really a way to like download a giant image onto like a small device and then only load it on like a small in a small container. This is why we want to introduce downsampling image policy, so that we set a limit, like this is how much we can downsampling an image. If the image is too big, then we'll just maybe render it with inverted color, so that in like when the web developer is developing and testing the web page, they will notice, oh, something is wrong, so they will fix the problem, so that in production mode, all the problems will be gone.
So you're sort of using it almost like an assert, or in that situation.
Yeah.
Okay.
Yeah, and I mean, I think what we found in like internal consultations that Google has done with partners is that the top of the list is go get your images right. You're using unoptimized images. Either they're too big, you haven't compressed them, or like this example, you're shipping all these bytes for a big image and you really only need half the bytes or whatever. So, but yeah, it's exactly. The idea is it is like an assert, right? This is one way to make sure you're doing the right thing, is you lock in, maybe you do development time and, oh, that's great, I think I've got it right, but then, you have a large team. Not everyone might be following the script, and this is a way to catch these kind of mistakes.
Got it, thank you.
Yeah, thanks. Guess it's lunchtime for everyone.
Yep.
So, thank you, everyone.
All right, thank you.